Our focus standard for this lesson comes from grade 7, Geometry Standard 4. Know the formulas for the area and circumference of a circle. Our topic comes from Analyzing Geometry Relationships, Circumference and Area of Circles. Our essential question is, how do we use pi to calculate the area and circumference of circles? Please take a moment pausing the video if you need to copy down the topic and essential question into your header, along with today's date, of your question column and your note column, and resume the video when you're ready to begin. We're going to start today reviewing the parts of a circle. So I've left the vocabulary up here and a diagram. So let's just take it one step at a time. This thick black line around the outside edge of the circle is the circumference. Circumference is what we refer to as the distance around the outside of the circle, and you can kind of think of it as being like perimeter. The center is this pink point right here. Therefore, the center, being that point right in the middle, is exactly that. It's the exact middle point of the circle. This blue line that we see running edge to edge through the center is our diameter. So the diameter is the distance from one edge of the circle to the opposite edge through the center point. The radius is from the center point to the edge of the circle, or vice versa. It's half the distance of the diameter. So the radius is defined as being the distance from the edge of the circle to the center point. Now that we've reviewed the parts of a circle, let's jump into calculating the circumference of a circle. So if we are calculating the circumference, we're using either the measurement of the diameter or the radius to determine what the distance is around the outside edge of the circle. And, as our essential question alluded to, we're going to use the value pi to help us do that. The formula for calculating circumference is c, standing for circumference, is equal to the diameter times pi. Today, in this video, we're going to be using the approximation of pi 3.14 to do our calculations. Let's do our first problem. So here we have a circle with a diameter that is equal to 5 meters. So the distance from edge to edge through the center point of the circle is 5 meters. So let's use our formula to calculate the circumference. So every time we use a formula, we want to be in the habit of writing it out. So here I've done that. And then to follow it with a line where we substitute in the values we know. So we know that the diameter is 5, and as I mentioned, we're using the approximation of pi, 3.14. So all we have to do is multiply those numbers together, and we'll know the distance around the outside, or the circumference, of that circle. In doing so, we find that the circumference is equal to 15 7/10, and we always want to include our units of meters. So we've calculated the circumference using the formula, knowing the diameter of this circle was 5 meters. Let's try another one. Sometimes with a circle, they'll only give us the measurements of the radius. So here it's telling us that on problem number 2, the distance from the center point to the edge is 2 inches. So before we can do our work to calculate the circumference, we need to figure out what is the diameter so that we can use our formula. Since the radius is always half of the diameter, because the diameter is the total distance, we can take our radius, multiply it by 2, and that will tell us our diameter. So we know that the diameter for this circle would be 4 inches. Now we're ready to begin our calculations. Feel free to pause the video here, set up your formula, plug in your values, and see if we agree on the circumference. Did you remember to set it up correctly? Always write the formula and then plug in the values. And if you've done that, then we should agree that the circumference is 12 56/100 inches. That would be the total distance around a circle with a radius of 2 inches. Let's try our third problem for calculating circumference. Here's the third type of problem. Sometimes they'll give us the circumference measurement and ask us to find the diameter. So if we know that the circumference of this circle is 21 and 9800 centimeters, we're still going to plug in what we know for our formula of the circumference formula and then do some equation solving to find the diameter. So there's our formula. We plugged in over here below C that we know the circumference is 21 and 9800ths. We set that equal to the diameter, which we left as D because we're solving for that, times the approximation for pi, 3.14. So using our equation solving skills, what do we have to do to get this variable D by itself? If you said to divide both sides of our equation by 3.14, I would agree, because we're doing the opposite operation as what's in the formula here, where we're multiplying by 3.14. So if we divide both sides by 3.14, we should get that this cancels out, leaving D by itself for the diameter, and 21 and 9800ths divided by 3.14 is 7. So the diameter of this circle would be 7 centimeters. That means from one edge to the other edge of the circle, using a straight line, through the center point, that measurement would be 7 centimeters. Let's try calculating the area of a circle. With calculating the area of the circle, we're always trying to figure out how many squares fit inside or to cover the inside area of the circle. And what mathematicians have discovered is that the area of the radius square, meaning taking this measurement from the center of the circle out to the edge and out to the edge this way, and a 90-degree angle, making this complete square. So r times r is the r square, the radius square, fits inside of the circle pi times 3.14 times approximately. So the formula for finding the area of a circle is pi times the radius squared. So this formula, a equals pi r squared, will be the formula that we use to calculate area. Let's go ahead and try that with this problem here, where we are given a circle with a radius that is equal to 3 millimeters. Just like before, we're going to write out our formula, area equals pi r squared, and fill in the values that we know. We're still using the 3.14 approximation for pi. We know that our radius is 3 and it has to be squared. Now, to begin our calculations, we have to follow PEMDAS. So that means we have to take 3 squared before we can multiply it by pi, which leaves us with the area being equal to 3.14 times 9. In completing the calculation, we find that the area is equal to 28 and 2600ths millimeters squared. Let's try another problem. In the second problem for calculating area, we're given the diameter, which is equal to 8 inches. Much like before, in this case, we need the radius for our formula. So we just have to think about, if we know that the total distance from edge to edge through the center is 8, the radius will be half of that. Therefore, if the diameter is 8 inches, the radius will be 4 inches. Now we're ready to begin our calculations. Feel free to pause the video here and try to calculate the area of this circle using a radius of 4 inches, and resume the video when you're ready to check your work. So we've written out the formula, a equals pi r squared. We've plugged in the values that we know, and we're ready to begin PEMDAS to complete our calculations. So the next line should read that the area is equivalent to 3.14 times 16, because that is 4 squared. And in doing so, we find that the area of this circle is 50 and 2400ths inches squared. Remember, when finding area, we always use the exponent of 2 on our units because we're finding how many squares cover the surface of the circle. Let's try our last problem. Just as with circumference, sometimes we can be given the value of the area of the circle, and we can use our area formula to then work our way through to find the radius. So let's go ahead and give that a try. As with before, we're going to always write out our formula and then substitute in the values that we know. So in this case, substituting 113 4/100 for the area being set equivalent to 3.14 times the radius squared, leaving r for the radius because that's what we're going to solve for. So now we can think of this like backtracking. We want to get r squared by itself. So what's happening to that? Well, it's being multiplied by 3.14. So that's what we need to undo. So if we divide both sides by 3.14, we can cancel this out and find out what r squared is equal to. So dividing by 3.14 on the right hand side cancels this out, and 113 4/100 divided by 3 14/100 is 36. So 36 is equal to r squared. So what that means is that the area of one of these squares created by the distance of the radius is 36. We want to know just one side. What is this distance here from the center to the edge? That would be r. So to undo r squared, we have to take the square root of both sides. So if we take the square root of both sides, that leaves r, the radius, and the square root of 36 is 6, because 6 times 6 equals 36. So in using our formula, plugging in what we know, and using our equation solving skills, we find that the radius of this circle, the distance from the center point to the outside edge, is 6 yards.